know what time it is. It is time for the periodic table series. This is episode 2. We are going to be doing helium. So let's find helium. Hold on. Okay. Helium. Not much here. What's it? Well, it flew away. Almost flew away. Helium is the second lightest element after hydrogen. This transparent gas was discovered in 1868 by Sir William Ramsay, a Scottish chemist. Today, we know that a quarter of all atoms in the universe are helium. It is one of the main gases in the atmospheres of giant gas planets, such as Saturn. Being so light, however, helium is very rare on Earth. It escapes from our atmosphere into space. It was not until 1895 that chemists managed to collect a sample of helium gas coming from uranium. Guess what? No. You don't see any other things, but whenever I show the entire page. A radioactive uranium mineral. Today, helium is collected from underground reservoirs or is found mixed in natural gases and oil. Unlike hydrogen, which is very reactive, helium is a noble gas and does not react at all. This property makes it safe to use in objects such as party balloons and airships. To turn helium into a liquid, it must be cooled to an extreme temperature of negative 452 Fahrenheit, which is negative 269 Celsius. Liquid helium is used to make things very cold, including the powerful magnets used to make maglev trains float along special tracks. MRI scanners also use liquid helium for cooling. Okay. Also, Saturn's atmosphere is made up of clouds of hydrogen and helium. Natural gas often contains some helium. A particle accelerator is a machine that smashes together atoms. This one uses liquid helium to cool its apart. I'll show you that, and then also this one, this is a sample of helium trapped in a gas sphere. Helium is a transparent gas, but it glows purple when electrified. Helium-cooled MRI scanner. Party balloon. This balloon contains a mixture of helium and air. Helium-cooled maglev train. The high-speed train uses a pair of magnets, one to move forward and one to float over the track. Helium-ion microscope. This powerful microscope can zoom in to view much smaller details than most microscopes. Airship. The airship contains large quantities of helium to make itself lighter than air. Rocket helium tank. Helium in this container will fill up a rocket's fuel tanks as they empty off during liftoff. Did I already say helium-cooled MRI scanner? I don't know if I did, but this one I didn't say what it is. This machine contains a system that scans the organs of a patient. Sun gases. In 1868, during a total solar eclipse, when the moon passes directly in front of the sun, helium was discovered in the cloud of gas seen around the sun. The yellow color of this cloud showed it contained an unknown gas which was named after Helios, the Greek god of the sun. Yeah, here is the thing I was talking about there, and then that, and then that, and then while we're here, let me just show you the rest of the page. So that is it for episode 2. Oh, we got another thing. Nebula. This glowing nebula, clouds of gas and dust, is the Crescent Nebula. I'll show you at the end. It is so vast that our entire solar system would fit inside it 7 times over. The nebula's light comes from a superheated star at its center, known as WR 136. This star is 15 times heavier than our sun and 250,000 times brighter. And 250,000 times brighter. Its immense power comes from its fuel, helium. Helium makes WR 136 hot and bright. The star once burned using hydrogen like our sun. Hydrogen atoms smashed together in the star's core until they became helium atoms, releasing energy in the process. However, that star ran out of hydrogen about 200,000 years ago. It began smashing together helium atoms instead and ballooned into a gigantic red star, sending out a cloud of gas that spread around it. The star is producing a wind of electrified gases that hurtles out 1,056 miles, which is 1,700 kilometers every second. This wind continues to crash into the gas cloud, making it glow into the nebula we see. Eventually, WR7 will run out of helium and its other fuels and explode in an enormous fireball called a supernova. Let's show this page. And that is the end. Goodbye. In episode 3, I do have something special to show.